Okay, so like when you're talking to Chat GPT, right? Or, one of those AI things, it's almost creepy how well it seems to get what you mean. Like, how do they even take our words and, actually make sense of them?
It's really remarkable, isn't it?
Yeah. So that's what this whole deep dive is about today. We're really going to try to understand how these things work. And specifically, we're looking at these things called transformers.
Right. And transformers are really kind of a revolution in AI.
Yeah. And we're focusing on one part of that called the encoder, which is basically like the brains of the operation where it all starts.
It's where the language processing really kicks in.
Right. And to help us unpack all of this,
Yeah.
we have this visual guide from Josep Ferrer, which is seriously amazing. It's like he took this incredibly complex topic and made it clear.
Yeah, visualizations are really helpful when you're talking about something this intricate.
Totally. So maybe before we get too far, can you just give us a high-level overview? What does the encoder actually do?
So, at the most basic level, the encoder takes human language, like what we're speaking now, and it breaks it down into something that the AI can actually understand, which is numbers. It's kind of like translating English into math.
Oh, okay, so the AI isn't really understanding English like we do.
Not exactly.
It's more like it has its own numerical code book or something?
Yeah, you could put it that way, and that's what we call input embedding. It's basically like imagine a giant map where every single word has its own unique location, like coordinates. And those coordinates, that's essentially what an embedding is.
So each word gets its own secret code,
Hmm.
and the AI uses those to start understanding us.
Exactly. And it's not random, it's based on the relationship between words. So, like the word bank by itself has multiple meanings. But if the AI also sees words like river and flow nearby, it can start to figure out which bank we're talking about.
Oh, that makes sense, like context clues for AI.
Yeah.
But words in a sentence aren't just, all jumbled together, right? The order matters. So how does the encoder deal with that?
That's a great point, and you're absolutely right. Word order is crucial for understanding. That's where something called positional encoding comes in. It basically gives the AI a sense of grammar, even though it's working with numbers. So each word's position in a sentence is factored into its numerical representation.
So is that how the AI knows the difference between the cat chased the dog and the dog chased the cat? Because it's the same words, but totally different meanings?
Precisely. Positional encoding is how the AI gets this basic understanding of, syntax and sequence.
Okay, this is already kind of blowing my mind. We haven't even gotten to the really mind-blowing stuff yet.
Yeah.
So we've translated our words into numbers, and we've given them a sense of order. But how does the AI actually go from there to understanding the relationships between the words?
I think
Because that's where things get really interesting. Oh.
absolutely. And that's where we get to the heart of the transformer, the self-attention mechanism.
Ooh, that sounds very mysterious.
Mhm. And we'll dive into that right after the break.
Okay, so last time we were talking about, how the encoder kind of does this whole translation thing, takes our words, turns them into numbers, figures out the order they go in. But how does it go from there to like actually understanding? That's where the self-attention comes in, right?
Yeah, exactly. Self-attention is how the transformer figures out how all those words relate to each other, even if they're not, right next to each other in the sentence.
Okay, but how does it do that? Is that like some super complicated math thing?
Well, there's definitely math involved, but the idea is actually pretty simple. Imagine each word is like a detective, and they're all working together to solve this mystery.
Okay, I like this analogy. So each word is like looking for clues.
Exactly. Self-attention is like giving each word the ability to look at all the other words
Hmm.
and figure out, which ones are the most important for understanding its meaning. And to do this, it uses these three things: query, key, and value.
Right. You mentioned those before, but I'm still a little fuzzy on like what they actually
Mhm.
do.
Okay, so think of it this way. Each word has like three versions of itself: the query, the key, and the value. The query is like the word saying, hey, everyone, this is what I'm all about. Does this ring a bell for anyone?
So the query is kind of like the word's way of, putting itself out there looking for a connection.
Exactly. And then the key, that's like a label on each of the other words. It's like their way of saying, this is what I'm all about. Do we match?
Okay, so it's like a matchmaking service for words. I kind of get it now, but what about the value?
Right. So the value, that's where the actual information comes in. Once the query has found its best matches, by comparing itself to all the keys, it focuses on the values of those matching words.
So it's like saying, okay, I found the words that matter most to me. Now let me really listen to what they're saying.
Exactly. And the way it determines those best matches is through some math. It calculates a score for each query and key pair to see how compatible they are.
Hold on, before we get too deep into the math, can you give me an example, like with the real sentence?
Sure. Let's say we have the sentence, the cat sat on the mat, but it wanted to play. Now, the word it on its own doesn't tell us much, right?
Right.
But with self-attention, the it query can look at all the other words, and it realizes that its key matches up really well with the key for cat.
Because it is referring to the cat.
Exactly.
Wow.
So the it query focuses on the cat value, and it understands that it means the cat in this sentence.
Okay, that makes so much more sense now. It's like each word is judging out its role in the sentence. But you said earlier that the self-attention thing happens multiple times. Why is that?
Yeah, that's the multi-headed part of multi-headed self-attention. And that's where things get even more interesting.
Okay, multi-headed self-attention. It sounds kind of scary, like some kind of sci-fi thing. Are there
Which,
like a bunch of little AI brains in there or something?
no, it's not quite like that. But you're on the right track with the multiple part. Instead of just like one set of eyes looking at the relationships, we have multiple heads, and each one focuses on a different part of the language.
Oh, so it's like having a team of detectives, each with their own specialty.
Yeah, exactly.
I like it.
Like one head might be really good at figuring out which words refer to the same thing, like that it and cat example we talked about. And then another head might focus on how words modify each other. Like, is it a fluffy cat or did it chase quickly? you know?
Okay, so it's adding like another layer of depth, letting the AI understand those little nuances.
Exactly. And each head does its own self-attention thing, comparing queries and keys, finding the best matches, and then using that to refine the word representations.
Wow. So we've got all these heads working at the same time, building up this really complex understanding of the sentence. But what happens next? How does it all come together?
Well, all the outputs from those different heads get combined. So you end up with this even richer representation of the input.
So it's like taking all the reports from those detective teams and putting them together in one place.
Exactly.
And that's like the final output of the encoder.
Almost. There are still a few more steps to make sure everything is accurate and, ready to
Okay,
go.
so what else is there?
It's kind of like fine-tuning an instrument. We have all these rich notes from the self-attention, but we need to make sure they're all in tune and playing together nicely.
Right.
And that's where a few more technical things come in, like matrix multiplication and something called softmax.
So it's like making sure all the different parts are balanced and working together.
Exactly. And then to make sure we don't lose anything important along the way, we use this technique called residual connections.
Okay, what does that do?
It's like keeping a backup copy of those word representations as we're refining them, just in case.
So it doesn't accidentally forget something it learned earlier.
Exactly. And then finally, the information goes through one last stage, a feed-forward network,
Oh,
which
yeah.
basically takes everything the encoder has learned so far and kind of polishes it up.
So it's like the final layer, the finishing touch.
Exactly. And with that, the encoder has done its job. It took human language, broke it down, analyzed it, and turned it into something the AI can actually use.
Wow, it's amazing how much is happening in there. But I have to ask, what does all this actually mean for us? Like when we're using these AI tools, what happens to that final output?
Well, it gets passed on to other parts of the transformer. So if it's a translation model, it'll use that information to generate text in another language. Or if it's a chatbot, it'll use it to figure out how to respond to what you said.
So it's like the encoder gives those other AI systems the keys to the kingdom. That's incredible.
It really is. And what we talked about today is really just scratching the surface. The field of AI is always changing, and transformers are leading the way.
It's pretty mind-blowing when you think about it. Well, this has been an amazing deep dive. I feel like I actually understand a little bit about how these AI models work now. It's not just magic anymore.
Exactly. It's really elegant when you get down to it.
Totally. So if you're listening to this and you want to learn even more, definitely check out Josep Ferrer's visualization. It's a really amazing resource. And until next time, keep exploring and keep asking those big questions.